Okay, so we're going to continue on with what we were doing the other day. It's a little different today, but it's still the same idea. This is actually, I find this to be easier than what we were doing the other day. Because again, the biggest trouble that people have is setting up the picture. Once they get the picture correct, usually finding sine, cosine, tangent, all that other stuff is a little less stressful. So you have pretty much the same 5 steps. What we're going to be doing today, you're going to have to find all 6. I'm not giving you any, right? On Monday, I had given you 1, and you had to find 5. Now, I'm not giving you any, but I'm asking you to find all 6. And the way you're going to do that, you have to be given the coordinate, or the point, that the angle intercepts. Okay, so first step is draw the angle. Second, create a right triangle with the reference angle. Everything stays the same for the most part. Okay, the last step is the only thing that's different because now you're finding all trig functions rather than just the 5. All right, so let's look at your first example. Find the exact value of all 6 trig functions. Of all 6 trig functions of angle theta in standard position if the point 4, -1 lies on its terminal side. So now the difference here too is that I don't tell you specifically what quadrant it's in, right? But you have to think 4, -1. For the 4, you would go to the right, and then from the origin, you go 4 over to the right, and then you go 1 down. So this is going to be in quadrant 4. Okay, so this is how you can picture it if you want. You can put any point that you want, right? This is the angle that it's going to intercept, and then you're going to create a right triangle with the reference angle, so you go up. So this point is 4, -1. So if that's 4, -1, right, this is going to be your distance. This here is 4, and this is -1. And then you are going to be finding the hypotenuse here, right? This is the hypotenuse. I'm sorry, that's the right angle, right? The right angle is the one that you can make a box in. And then theta is in the triangle closest to the origin, so that's theta, okay? So what you're looking for is across from the right angle, so you're looking for your hypotenuse. So your next step, you're already at step 4. Use Pythagorean theorem to find the missing sides. So because you're looking for the hypotenuse, you're looking for C. So you have 4 squared plus -1 squared equals, if you want to write C squared, you can. X squared doesn't matter. 4 squared is 16 plus -1 squared is still +1 equals x squared. 17 equals x squared, so x is equal to the square root of 17. So this is the square root of 17. The nice thing about whenever you're given a point instead of one of the trig functions is that it kind of tells you what's positive and what's negative in your triangle anyway, right? Because here, this 4 is positive and the 1 is negative. Hypotenuse is always going to be positive. So then from here, using that picture, we can figure out what sine, cosine, tangent is, and then we can do the other 3 remaining trig functions. So let's do sine first. Sine, again, is opposite over hypotenuse. All right, so opposite, let's label this quick, actually. Opposite angle theta is across from it, so -1 is opposite. The hypotenuse is across from the right angle, so that's the square root of 17, and 4 is the adjacent side. It's right next to it, but it's not the hypotenuse. All right, so now using this, we can let's find sine, cosine, tangent first, and then we'll flip them to find the reciprocals. So sine of theta is the opposite, so -1, over the hypotenuse is the square root of 17. Cosine of theta is adjacent over hypotenuse, so adjacent is 4, divided by the hypotenuse is the square root of 17. Tangent of theta is opposite over adjacent, so -1 over 4. Now I know you're looking at the square root of 17 in the denominator. I'm going to explain that again in a second. And once you have these 3, you really don't need to look at the picture anymore because the reciprocal functions are all of these just flipped upside down. right? That's what a reciprocal is. You flip the fraction. So the reciprocal of sine is cosecant. And the reciprocal of negative 1 over the square root of 17 is negative square root of 17 over 1. I'm not going to put the over 1. If you want to, you can. Reciprocal of cosine is secant. And the reciprocal of 4 divided by the square root of 17 is the square root of 17 divided by 4. Reciprocal of tangent is cotangent. Reciprocal of negative 1 over 4 is negative 4 over 1. I'm not going to put the over 1. You can if you want, though, okay? So now notice sine, cosecant, tangent, and cotangent are all negative, but cosine and secant are positive. If you remember, all students take calc, quadrant 4, only cosine, and it's reciprocal, so secant should be positive. So that's one thing. Now the other thing is this, these denominators. So it's only sine and cosine that have radicals in the denominator of the fraction. So if we look at these, the way that we get rid of a radical in the bottom is by multiplying that fraction by the radical. And this is the reason why. When you do, so for example, negative 1 over the square root of 17, you would multiply the top and the bottom by the square root of 17. The reason why is because the square root of 17 times the square root of 17 is really the square root of 17 squared, right? 5 times 5 is 5 squared. Square root of 17 times the square root of 17 is the square root of 17 squared. It's the same thing, it's just a lot wordier. Okay, so you have the radical and the 2 and the square cancel each other out to give you 17. So now I only have a 17 in the bottom. There's no square root. I don't care if there's a square root in the top. I have to rationalize the denominator. Just no radical in the denominator, okay? And then negative 1 times the square root of 17 is negative 1 square root of 17. These 17s do not cancel out because one is in a radical and the other is not, okay? Now we're going to do the same thing for the cosine. We have 4 divided by the square root of 17, so we multiply the top and the bottom by the square root of 17. So on the bottom, the square root of 17 times the square root of 17 is 17. And then on the top, 4 times the square root of 17 is 4 square root 17. And that's it for number 1. Whoa. Okay, that's all 6. Okay, let's look at number 2. Same thing, but now our point is negative 2, 3. So negative 2, 3. If you're not good at visualizing where that is, just draw a big coordinate grid. Right? This is the origin. So negative 2, 3, you go left negative 2, up 3 is somewhere up here. Right? So then I draw a right triangle. Again, negative 2, comma 3. So you go left negative 2, up 3. So this is your right angle. This is your right angle, and this is your theta. Remember, theta is always in the triangle, okay? Again, you're looking for the hypotenuse, right? Because, again, if we go from theta, this is the hypotenuse. It's across from the right angle. 3 is opposite, and negative 2 is adjacent. So we have 3 squared plus negative 2 squared equals x squared. Whenever you're given a coordinate, you're always going to be looking for the hypotenuse. So 3 squared is 9 plus negative 2 squared is 4 equals x squared. That's 13 equals x squared. So x is equal to the square root of 13. So that is now my full triangle. So then from here, we can do sine, cosine, and tangent. And then from there, we can flip them all. So we have sine of theta. Sine of theta, that's opposite over hypotenuse. So 3 divided by the square root of 13. Cosine is adjacent over hypotenuse. So negative 2 divided by the square root of 13. And tangent of theta is opposite over adjacent. So 3 over negative 2. Negative 3 over 2. Doesn't matter if you put the negative in the bottom. We're going to pause on doing the radicals in the bottom for a second. Let's do the reciprocals. Reciprocal of sine is cosecant of theta, and the reciprocal of 3 divided by the square root of 13 is the square root of 13 divided by 3. Reciprocal of cosine is secant. Reciprocal of negative 2 over rad 13 is negative rad 13 over 2. And then reciprocal of tangent is cotangent. And then you flip negative 3 over 2 to give you negative 2 over 3. Okay, so let's talk about sine and cosine, because again, those are the ones that have the radicals in the denominator. To rationalize this, you multiply the top and the bottom by the square root of 13. Square root of 13 times the square root of 13 is 13. 3 times the square root of 13 is 3 square root 13. That's it. For cosine, multiply top and bottom by the radical, which again is the square root of 13. Square root of 13 times the square root of 13 is 13. Negative 2 times the square root of 13 is negative 2 square root 13. And that's it. Last one. Negative 3, negative 7 is on the terminal side. So again, negative 3, negative 7. Negative 3, you go to the left. Negative 7, you go down. So your point is somewhere here. So this is what it's saying. Angle theta is in standard position. The point lies on the terminal side. The terminal side is where the angle ends. Right? So if this were my angle all the way around, and that it just happens to intercept that point. That's your reference angle. Again, we are at, what was it, negative 3, negative 7. So negative 3 is the x, negative 7 is the y. This is your right angle, and this is your theta. Not an 8, theta. So if you want to label your signs now, feel free. Negative 7, I'm sorry, is opposite the theta, so that's O. Across from the right angle is your hypotenuse, and negative 3 is the adjacent. So again, just like I said before, you're always going to be looking for the hypotenuse in these types of examples. So we have negative 3 squared plus negative 7 squared equals x squared. If you want to write equals c squared, feel free. If you want to write equals h squared, feel free. It doesn't matter. Negative 3 squared is 9. Negative 7 squared is 49 equals x squared. You add the 2, you get 58 equals x squared. So x is the square root of 58. Okay, so we are going to do sine, cosine, and tangent again. Sine is opposite over hypotenuse. Opposite is negative 7. Divided by the hypotenuse is rad 58. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So now it's negative 7 divided by negative 3. The negatives cancel out, so really you should write this as 7/3. 7 over 3. The negatives cancel each other out. So then let's do the reciprocals. Reciprocal of sine is cosecant of theta equals, you flip the original, so it's negative square root 58 over 7. Reciprocal of cosine is secant. You flip cosine, you get negative square root 58 over 3. And then cotangent, you flip 7 over 3, and you get 3 over 7. And then lastly, you rationalize these two denominators. Again, sine and cosine are what has to be rationalized. It's not always going to be sine and cosine. That's just what happened in this case. So you multiply the top and the bottom by the radical. In this case, it's the square root of 58. So sine of theta is negative 7 divided by the square root of 58. However, more appropriately is negative 7 square root 58 divided by 58. These two things this one here and what we just wrote, they have the same equivalence. They're the same number, it's just written in a different way, in a way that we like, where there's no radical in the bottom. And now for cosine, you multiply it. Again, it's the same radical, so you multiply the top and the bottom by the square root of 58. Negative 3 times the square root of 58. Negative 3 square root of 58. Divided by, and then rad 58 times rad 58 is 58. Okay, let me know if you have any questions. That's your full answer for number 3, sorry. Okay.